Now that we've learned how to change the case of text, how to change date formatting, and how to trim white space from data, in this video we'll discuss how to use the flash fill and text to columns features in Excel to help clean data. We used flash fill briefly earlier in the course as a quick method of entering data that fits a specific pattern, such as the names of months or days of the week. But it can also be used as a data cleaning tool. It can split a column of full names into two separate columns for the forename and surname, and it can also help to modify the naming convention used in a column of names. For example, in the Vehicle Toy Sales worksheet, there is a column containing the last names of contacts and another containing their first names. If you want to use the flash fill feature to combine these names into one name column, you first insert a helper column. Let's call it Contact Name. Then, in the first row in the new column, you enter the full name of the first contact in the format of your choice. For example, you might want surname, then a comma, then the forename. Or you might want surname and just an initial, and so on. In this case, let's just enter the name in the standard format of forename, then surname, with a space between them, and then we press Enter. Next, you'll start typing the second contact's name, and you'll see that Flash Fill displays a preview of the remaining names for you. If you're happy with what's in the preview, all you have to do is press Enter, and it fills in the remaining names for you right down the column. It even works when there are two names in one of the columns, such as Wing C here and Dakuna here. Now you can remove the original columns if you no longer need them. So in the previous task, we saw how to combine two columns of data into one column using flash fill. Now let's see how to use it to modify the naming convention in a column. Let's switch to the Customer Contacts worksheet. Then, in the first data row of the next column, that is B2, we type the name of the first contact using whatever naming convention we want. We'll use surname, then comma, then space, then the forename, and press Enter. Again, when we start typing the second contact's name in the next row down, that is B3, Flash Fill detects the pattern and fills in the remaining names in column B when we press Enter. You could then copy and paste the column header and delete the original column A. What we couldn't do with flash fill was take a single column with two names in and split that into two separate columns. We need to use the text to columns feature to do that. So we'll close this worksheet and we won't save the changes. Now let's see how the text to columns feature can help with data cleaning too. As the name suggests, and unlike flash fill, the text to columns feature can take a column containing multi-part text and split that text into one or more other columns. This can be useful for splitting any multi-part text, such as names or addresses, into separate component parts. Let's open the Customer Contacts worksheet again. Then we'll add column headings for the next two columns and copy the cell format used in the first column header. Then we'll widen the columns. If we then select the data in column A from A2 to A23, and on the Data tab click Text to Columns, a wizard is launched. On the first page of the wizard, ensure that Delimited is selected. On the second page, ensure that only Space is selected as the delimiter. On the third page of the wizard, click the little arrow next to Destination and select B2 on the worksheet. Then click the little arrow again to return to the wizard. We're now finished with this wizard. You can now see that the full customer contact names in column A have now been successfully split into two new columns in B and C. And you could now remove column A if you no longer need it. We'll close this worksheet, and again, we won't save the changes. You can also achieve the same result using functions. This would be required if you were using Excel for the web, the online version of Excel, as this doesn't have the text to columns feature. There's also a bit more flexibility with functions, which can be especially useful if you have names that are complex and mixed, such as having hyphenated names, or some names with a middle name, some with two middle initials, and some with no middle initial. So we open the Customer Contacts worksheet again. Then we'll add column headings for the next two columns and copy the cell format used in the first column header. Then we'll widen the columns. Next, we'll enter the formula in B2 to extract the forename part of the name. This formula extracts 5 characters from cell A2, starting from the left and including the space. Then, in cell C2, we enter the formula to extract the surname part of the name. This formula extracts 7 characters from cell A2, starting from the right. Then we'll double-click the fill handle in cell B2 to use autofill to complete the column. And we do the same to the fill handle in cell C2 to use autofill to complete that column also. In this video, we learned how to use flash fill and text to columns features in Excel to help clean data. Now that we have learned how to collect and clean our data, it is time to decide the best method for analysis. In this video, we will discuss the importance of filtering, sorting, performing calculations, and shaping our data to provide meaningful information. Deciding how to manipulate our data can sometimes be difficult. Before we make any changes or adjustments, we will need to visualize the final output. Below are some questions to ask before beginning the task. How big is the data set? What type of filtering is required to find the necessary information? How should the data be sorted? What type of calculations are needed? Now that we have visualized the final output, we must decide the best approach to shape our data. The most basic step would be to filter and sort the data. By sorting the data, we are able to organize it based on conditions, such as alphabetically or numerically. For example, if we wanted to check for duplicate order numbers, we could sort the data and quickly see any duplicates. After sorting and removing the duplicate row, we find that the view needs to be more specific to meet our requirements. We now decide that we only want to see the data for the month of November. By adding a filter, we can now choose to only see items with a month ID that is equal to 11. By filtering our data, we are now able to only see the rows that meet the filter criteria, and it allows us to better analyze our information. Becoming familiar with all the tools to analyze data can seem daunting, but one key benefit of using a spreadsheet is the ability to use functions. Functions in Excel are organized by several categories, including mathematical, statistical, logical, financial, and date and time-based. Let's say we wanted to get an average of company revenue for the month of June. We realize there are over 100 items that would need to be calculated. In normal circumstances, to get an average, we would have to create a formula to add each row and divide by the total number of rows. This type of calculation would not only be very long, but can expose the analyst to possibly making a mistake. With the use of a function, we would be able to simplify our calculation in one easy step. Equals average, open parenthesis, B1, colon, B160, close parenthesis. While sorting and filtering data on our spreadsheet can be useful on its own, first converting your data to a table has many benefits. When we convert our data into a table, we are able to filter and calculate the data more efficiently. One example is the ability to easily calculate columns. For the column MSRP, we choose Sum, and we're able to quickly calculate the sum of the column. If we then look at the data, and we only want to calculate the MSRP total based on Japan, we would filter the country column to only display Japan, and the column would then only add the values in the rows that were associated with Japan. While all data may not work in a table, there are quite a few advantages to formatting your data as a table. Automatic calculations even when filtering. Column headings never disappear. Banded rows to make reading easier. Tables will automatically expand when adding new rows. Sometimes data needs to be more organized than what a basic tabular format can give us, and creating pivot tables with charts can be a better way to analyze and display the required information. In Excel, we have the option of creating a pivot table to display and analyze our data, and optionally, an associated pivot chart. For example, Let's say we want to know what company ordered products in the month of October. From the original table of data, we create a pivot table to organize and analyze the required data, along with a pivot chart to display the information. By then adding the month filter to the newly created pivot table, we can see the results for the month of October not only in the table, but the changes are automatically updated in the pivot chart. When trying to single out specific information in a large data set, a pivot table is a nice way to show only the information that is required. This allows us to quickly and easily scan the essential information. Pivot charts are a nice accessory to pivot tables, as they allow us to visually process data and in most cases will let the audience grasp the information quicker. The advantages of selecting a pivot table and chart are: manipulate data without using formulas, quickly summarize large data sets, ability to display engaging charts and graphs. In this video, we learned about the importance of filtering, sorting, performing calculations, and shaping our data to provide meaningful information. And we learned about some of the tools to begin analyzing our data. In the next video, we will learn more about filtering and sorting our data. In the previous video, we learned how to use the flash fill and text-to-columns features in Excel to help clean data. In this video, we will discuss how to filter and sort our data to enable us to control what information is displayed and how it's displayed in our worksheets. Filtering your data enables you to gain more control over which parts of your data are displayed at any given time in Excel. This can help with the visibility of data by narrowing down the data to within specified criteria and parameters, and it can also help when searching for specific pieces of data. To filter your data, the first thing you need to do is turn filtering on, which is very simple. On the Data tab, click Filter, and that's it. You will now see a small filter icon next to each of the column headers. As a side note, if you want to only filter on one or more columns, select those columns first, then click Filter. As another side note, if you format your data as a table, the columns automatically have filter controls added to them. So now, each column has a filter that can be applied to the data in that column. In the Order Date column, you can filter on the years. In Product Line, you can filter on the different product types. And in Customer Name, you can filter on each customer by name. Let's first filter on the year. We'll select orders from 2004 only by deselecting the other year. And if you wanted to, we could expand the year and filter by months also, but we won't do that for now. If you look at the status bar at the bottom of the worksheet, you can see that there are only 50 out of 114 records now displayed. If you want to clear a filter, you can either click the Clear Filter From option or click the Select All item in the filter list. Now, let's filter on the Product Line column to display only the rows that hold data for sales of classic cars. And again, we'll clear the filter. Lastly, we'll filter on the Customer Name column and only display sales to Mini Gifts Distributors Limited. And then clear that filter. So far, we've only applied one filter at a time, but suppose you want to filter down to a greater degree. We can do that too by just enabling all those filters together. And now we are only displaying sales of classic cars to Mini Gifts Distributors Limited in 2004. Remember, if you only want to clear one filter, then click its filter button in the column header and click the Clear Filter From option. But if you want to quickly clear all filters, you can use the Clear button in the Sort and Filter group on the Data tab. So far, we've used what are commonly referred to as auto filters, but you can also use custom filters to specify other criteria to apply to a filter to text or numbers. For example, if you wanted to see sales orders that are over or under a certain value, you can do that with custom filters. For the sales column, let's add a number filter that only displays sales that are over $2,000. If you look in the status bar, you can see that we are now showing 111 out of 114 records. Then let's clear that filter and filter it the other way to display the sales orders that are below $2,000. We can see that there are only 3 orders that are below $2,000. It's important to note that the data rows that we don't see have not been removed. They are still there. They have just been hidden from view by the filters. And this is indicated by the row numbers you see on the left in blue. The row numbers start at 69 and jump in large increments, indicating that there are many more rows of data in our data set than are currently being displayed. Let's clear those filters. If we look at a column filter for a column that contains text, you will see that the menu item changes to text filters instead of number filters. And you can see that there are several text filter options. And if you want to turn off filtering altogether for a worksheet, just click the Filter button on the Data tab. Now let's take a look at the basic sorting capabilities in Excel. Sorting is a very important part of the role of a typical data analyst. You might need to organize your text-based data alphabetically, your number-based data numerically, or your date-based data chronologically. When you sort data using these logical parameters, it makes it easier for you to conceptualize and visualize your data in a more meaningful way. When sorting data, the first thing you need to do is select which data to sort. For example, if you want to sort your customers alphabetically, select a cell in the customer name column first, and then either sort by A to Z or by Z to A. And if you want to sort your sales figures numerically, select a cell in the sales column first, and then either sort from smallest to largest or from largest to smallest. And lastly, if you want to sort your customers' order dates chronologically, select a cell in the order date column first, then sort from oldest to newest or from newest to oldest. But you can also sort your data by more than one column at a time. Simply select a cell in your data, then on the Data tab, click Sort. Then either use the Sort by Column suggested or use the drop-down list to select a different column. In this case, we'll choose the Order Date column as our first sorting criteria, and we'll choose oldest to newest in the Order drop-down list. To add a further sorting level, you click Add Level. Then you choose another sort column in the Then By drop-down list. In our case, we'll choose Sales, and for this sort level, we'll choose largest to smallest in the order list. If you have a header row in your data, as we do here, then ensure you select the My Data Has Headers checkbox, then click OK to sort. So, the data is now sorted to list the oldest orders by order date first, then within each order date, if there are multiple instances with the same order date. Then, the next sorting level lists data by the largest order values first, down to the smallest order values. In this video, we learned how to use the filter and sort tools in Excel to filter and sort our data to enable us to control what information is displayed and how it is displayed in our worksheets. Now that we've learned how to use the filter and sort tools in Excel to filter and sort our data to enable us to control what information is displayed and how it is displayed in our worksheets, in this video we'll discuss how to use some of the most common functions a data analyst might use, namely if, ifs, countif, and sumif. First up, let's look at how to use the if function. The if function is one of the most used logical functions in Excel. The if function enables you to logically compare a value against criteria you set in the function, and then return a result based on whether the result of the logical comparison is true or false. And these values can be text values or numeric values. An if function essentially says, if something is true, then return a value or do something. But if it's not true, then return a different value or do something else. For example, in our vehicle toy sales worksheet, if we wanted to have a column that recorded whether the order had been shipped or not, you could add a new column to the right of the existing column, let's call it shipped, and then enter the formula seen in cell H2. This formula is saying if the text in G2 says shipped, then return yes, and if it doesn't, then return no. You can then use the fill handle to copy this formula down the column. You can see that most of the cells do say yes, but some don't, as the order hasn't been shipped for one reason or another. We could also use the if function to emphasize the size of an order. So, if we add a new column to the right of sales and name it 3K plus or minus, then enter the formula seen in cell F2. This formula is saying if the order is over 3,000, then return the text over 3K. But if it isn't, then return the text under 3K. And we can copy the formula down the column. In an ideal world, you would only use the if function to apply one or two conditions, but there may be scenarios where you would want to apply multiple conditions. In these cases, you can use the nesting capabilities of functions to bring together several if statements in one formula. These are called nested if functions. For example, if we add another column here for the order size, and then enter the formula seen in cell F2, you can see that this formula contains multiple if functions. One is needed for each condition, one for large, one for medium, and one for small, and it requires 3 sets of parentheses. So it's a relatively long and complex formula, but it does work. Again, we can copy the formula down the column. Even though Excel technically supports the nesting of up to 64 different if functions in a formula, it is not a recommended best practice. Having multiple if functions in a singular formula can become extremely challenging to manage. For example, suppose you come across a formula like this that you haven't used for some time, or even worse, was created by someone else. It could be quite difficult to work out how and why it is being used. Also, if your conditions increase, then you need to add more conditions to an already quite complex and long formula, which will only complicate matters more. To resolve this issue, a new function was developed called ifs. The ifs function is only supported on Excel 2019, Excel for Microsoft 365, and Excel for the web. As the name suggests, this function can replace multiple nested if functions being used in a single formula to simplify matters. So, if we add a further column for order size, but this time we'll use the ifs function instead. As you can see in cell G2, this formula only has one set of parentheses instead of 3, and only uses one function instead of 3. Let's copy that formula down the column too. Now let's have a look at another example of using the if function, but we'll combine it with conditional formatting too. If we switch to the car sales worksheet and add a new column to the right of the year resale value column and call it retention percent, then we enter the formula seen in cell G2, which will divide the year resale value by the original retail price. We need to format this as a percentage, and then we can copy it down the column. Next, we'll add a column to highlight the retention value for each car. The formula we add here in cell H2 uses the if function to state that if the percentage in the previous column is greater than 69%, then mark it as good. But if it isn't, then mark it as poor. Once again, we copy the formula down the column. We could also use conditional formatting to highlight the retention value percentages even more. We select H2 and on the Home tab, click Conditional Formatting and make a new rule. The condition in our rule will only format cells that contain a specific text value, and that value is the word good. And if it does match that condition, then format it with a dark green font and fill the cell in pale green. Let's copy that conditional formatting down the rest of the column. You can see that the cells that contain the word good are now formatted as we defined, but the cells containing the word poor are not. Let's add another conditional format rule. This time, we'll select Manage Rules because we are going to add another rule to our existing rule. The new rule will be the same as the previous one, with the exception of looking for a match with the word poor instead, and formatting those matching cells with red text and a pink background fill. And once again, we copy that down the column. Now, all the cells that contain the word poor are formatted as red text with a pink cell fill. Let's now have a quick look at how to use the COUNTIF function. COUNTIF is one of the statistical functions provided in Excel. You can use it to count the number of cells that meet a certain criterion, such as the number of instances where an employee's name appears in a list of sales invoices, or the number of occasions a particular part number appears in a list of purchase orders. Let's switch to the vehicle toy sales worksheet. Suppose you want to find out how many of the sales orders in the list went to customers based in the United Kingdom. We enter the formula you see in cell AD7. Note that when we are using text as a criterion, we have to enclose the text in quotation marks. So there were 6 sales orders in the UK. And if you wanted to discover the same thing for French customers, then you would just edit the existing formula or copy it and then edit it. You can see there were 14 orders for French customers. Notice that this time the text entered was in lowercase, and it still works, so names in this function are not case sensitive. And let's do the same for United States customers. There are 41 orders to customers based in the States. There is also a newer function called COUNTIFs, which applies criterion to cells across multiple ranges to count the number of occasions where all criteria have been met. This removes the need to use multiple COUNTIF functions in a long and complex single formula. The COUNTIFs function is only supported on Excel 2019, Excel for Microsoft 365, and Excel for the web. Now let's take a look at how to use the SUMIF function, which is a very commonly used mathematical function in Excel. You use the SUMIF function to sum the values within a specified range that meet specified criteria. For example, you might want to add up only the salaries that are over a specified salary level, or you might want to find the total of all sales of a particular product category. We'll enter the formula seen in cell AD10. This formula will add up each of the sales orders that have a total of more than $3,000. Again, notice that because we have used an arithmetic operator, that is, the greater than operator, we must enclose the criterion in quotes. If we specify a criterion that is only a number, we don't enclose it in quotes. So, the total sum of all orders that were over $3,000 is almost $470,000. You can also use wildcards, such as question mark and asterisk, when searching for partial matches, and you can also specify to extract values from a different column than the column where you have specified the criteria. For example, if we enter the formula you can see in cell AD13, it will sum all the car sales in column E for only those products in the product line column that end in cars. There is also a newer function called SUMIFs that you can use to sum cells based on multiple criteria. This removes the need to use multiple SUMIF functions in a long and complex single formula. The SUMIFs function is only supported on Excel 2019, Excel for Microsoft 365, and Excel for the web. In this video, we learned how to use the if, ifs, COUNTIF, and SUMIF functions. In the next video, we'll look at how to use the VLOOKUP and HLOOKUP reference functions. Now that we've learned how to use the if, ifs, COUNTIF, and SUMIF functions, in this video, we'll look at how to use the VLOOKUP and HLOOKUP reference functions. VLOOKUP is one of the most commonly used reference type functions in Excel, and it enables you to find data referenced in a lookup table. It stands for vertical lookup, and therefore is a useful tool when you want to find something in a table or a range by row. Shortly, we will look at HLOOKUP, which stands for horizontal lookup, which looks for data by column instead. VLOOKUP works by using a common shared key between the source data and the lookup data in the lookup table. A typical lookup formula would look like $VLOOKUP, open parentheses, B3, comma, A2 colon B12, comma 2, comma, false, close parentheses, where B3 is the lookup value, that is, the value or word you are looking for. A2 colon B12 is the lookup table or range, that is, the table array or range of cells that contains the lookup value. In a formula, Excel references this as table_array. The lookup table can be on the same worksheet or in another separate worksheet. 2 is the lookup column number, that is, the number of the column in the lookup table that contains the value you are looking for. In a formula, Excel references this as col_index_num. False is an optional parameter that determines whether the match found has to be exact, denoted by false, or can be approximate, denoted by true. In a formula, Excel references this as open square bracket, range_lookup, close square bracket. The square brackets round this argument in the formula signifies that it is an optional argument, whereas the others are required arguments of a VLOOKUP formula. If you don't specify the optional false or true parameter in your formula, it will default to false. That is, an exact match is required. You can also use the number 0 instead of false, and the number 1 instead of true. Okay, now let's see the VLOOKUP function in action. In the car sales worksheet, suppose we wanted a quick price list of our favorite cars. The first thing we need to do is put the column containing the value we want to search for in the leftmost column, as VLOOKUP requires this. Then we can delete the original column. We then enter the formula seen in cell V16, which is looking for the word Corvette in the table array from cell A2 to G156, and then looks for the value in the fifth column, in this case, the price column, that matches the row containing Corvette and returns an exact value of $45,705. Note that in this example, we are using a part of our existing data table as the lookup table or table array. Let's format that as US currency. Then we'll format it to 0 decimal places. In fact, rather than use the reference A25 in the formula, it will be easier to use the reference to the word Corvette in the mini table in this worksheet where our list of favorite cars is. So that is V5, and the formula still works. Now let's copy that formula up to the favorite car table above it in the worksheet. But there's a problem, because when we copied the formula, the cell references changed. This happened because, as we learned earlier in this course, the default state of cell references is relative, and we want them to be absolute in this case. So let's undo that copy operation. To make the cell references absolute, we need to add dollar symbols to all the cell references in the formula. This can either be done manually, or you can put the cursor in each cell reference in turn in the formula and press F4 each time to automatically add the dollar symbols. Let's try and copy the formula again, and this time it works. If we use the fill handle on cell W5 to copy it down to the rest of the cars, it doesn't work. In fact, we end up with the same result in every cell. Why? Because each one is referencing the same cells in the lookup value, because we used an absolute reference. All we need to do now is modify the formula to remove the absolute reference for just the row parameter in the lookup value part of the formula by removing the dollar symbol. So in cell W5, we change $V$5 to $V5, comma. Then, when we drag the fill handle down, it will copy the formula correctly, and all the prices will be changed to reflect their correct retail price. Lastly, to show that the two tables are now connected by this VLOOKUP function, if we change the retail price for the Chevrolet Corvette in the main data table in cell E25, the price will also change in the favorite car's price list. Let's now take a look at the HLOOKUP function, which, as we mentioned earlier, does the same thing and works in virtually the same way as the VLOOKUP function, but it looks for data in columns rather than rows. So, HLOOKUP looks for a word or value in the top row of a table, and then returns a value in the same column from a row specified in the table array. Therefore, you would use HLOOKUP if your comparison values were situated in a row along the top of a data table. In contrast, you would use VLOOKUP if your comparison values were located in a column to the left of the data you want to find, as they were in the previous task. Of the two functions, VLOOKUP is used far more frequently than HLOOKUP because of the nature of most data tables. The syntax for HLOOKUP is identical to that of VLOOKUP, except that you specify a row index number, referenced in a formula by Excel as row_index_num. This indicates the number of the row in the lookup table that contains the value you are looking for. Let's create a small lookup table on the right-hand side of our main data table. A few columns have been hidden in this worksheet to make viewing a little easier. So now we've got low HP, medium HP, and high HP in the top row of our lookup table. Next, we'll add wingding symbols as ratings for the 3 horsepower levels. 1 sad face for the low horsepower rating, 2 neutral faces for the medium rating, and 3 happy faces for the high horsepower rating. Now, let's add a new column to the right of the HP level column and call it HP rating. Then in cell L2, we'll enter the HLOOKUP function. This function will look for the value in cell K2, which in this case is medium HP, and it will look for it in the cell range from Y21 to AA22, which is our little lookup table, and it will return the answer it finds in row 2 of the table under medium HP and use an exact value. Note that we've used some absolute references in this formula too. Notice that what is returned is the text KK, so we need to format the cell using the Wingdings font. Now, when we double-click the fill handle, the whole column shows the HP rating symbols relevant to each row's HP level value. And we're done. Although VLOOKUP and HLOOKUP are regularly still used as the de facto functions for lookup references in Excel, there is a newer function called XLOOKUP. This version is only supported on Excel desktop versions from Excel for Microsoft 365 and on Excel for the web, as well as on Excel for iPad and iPhone and Excel for Android tablets and phones. XLOOKUP is an improved and combined version of VLOOKUP and HLOOKUP together. It can work in any direction, vertically or horizontally. It also uses separate lookup array and return array values, instead of a single table array and a column or row index number. In this video, we learned how to use the VLOOKUP and HLOOKUP functions in Excel to find and connect to data referenced in both vertical and horizontal lookup tables. In the videos coming up in the next lesson, we'll start to look at using pivot tables in Excel. Now that we've learned how to use the VLOOKUP and HLOOKUP functions, in this video we'll look at how to create and use pivot tables in Excel. We'll first look at how to format our data as a table, then how to create pivot tables and use fields in a pivot table to analyze data. And lastly, we'll see how to perform calculations in a pivot table. Having a worksheet full of informational data is all very well, But to really get some use out of it, we need to analyze it from different perspectives to find answers to questions related to the data. Now, we've already used features such as filters and formulas to draw mathematical and logical conclusions about our data. But not all questions can be answered easily using filters and formulas alone. In order to obtain usable and presentable insights into your data, you need something else, and that something else is pivot tables. Pivot tables provide a simple and quick way in spreadsheets to summarize and analyze data, to observe trends and patterns in your data, and to make comparisons of your data. A pivot table is dynamic, so as you change and add data to the original data set on which the pivot table is based, so the analysis and summary information changes too. A data analyst can use pivot tables to draw useful and relevant conclusions about and create insights into an organization's data in order to present those insights to interested parties within the company. Before you start to create a pivot table in Excel, it can be very helpful to first format your data as a table. The reason for this is not only to make it more organized and defined and to add table styles to your data, but primarily it makes it a lot easier when adding records to the data set. In the car sales worksheet, let's first select any cell within the data, and then on the Home tab in the Styles group, choose Format as Table. Then, choose a style from the gallery. Note that Excel automatically knows the boundaries of our data range, but we can change this if we need to. And ensure you select My Table Has Headers if indeed it does. After you click OK and the data has been formatted as a table, note the filter drop-downs at the top of each column. These are automatically added when you format as a table. If we now scroll down to the bottom of the table and start adding another row of data for another vehicle, when you click Tab or Enter, note that it is automatically formatted and included as part of our table. Okay, now let's see how to create a basic pivot table and how to use fields to arrange data in a pivot table. Just before we do that, there are a few things you should use as a checklist to ensure your data is in a fit state to make a pivot table from. And these are: format your data as a table for best results. Ensure column headings are correct, and there is only one header row, as these column headings become the field names in a pivot table. Remove any blank rows and columns, and try to eliminate blank cells also. Ensure value fields are formatted as numbers and not text. Ensure date fields are formatted as dates and not text. In the worksheet, we can just select any cell in the table. Then, on the Insert tab, we click Pivot Table. Note that in the Select a Table or Range box, the table name, Table 1, is already entered for us. If we hadn't just formatted this data as a table, we would specify the cell range here instead. Under that, we need to decide whether we want to create the pivot table on a separate new blank worksheet or on this worksheet. A new worksheet is the default and is the most commonly used option. So, a new blank worksheet opens, displaying some basic pivot table instructions in the graphic on the left of the worksheet, and a pivot table fields pane on the right. You can rename the worksheet for the pivot table if you wish. To build the pivot table report, we need to add some fields from the top of the pivot table fields pane to one or more of the sections in the bottom part of the pane. For example, if we want to find out the total sales for each model of car, let's drag the manufacturer field to the rows section of the report, and then we'll drag the model field there too. But this isn't really the way we want it to look, so we'll drag the manufacturer field to appear at the top of the rows section above the model, which makes more sense with our data. Next, we'll add the price field to the column section, but again, that really isn't the way we want to view the data, so we'll drag price to the values section instead, which makes a lot more sense and looks a lot better. Next, we'll add the unit sales field to values too. So now we can see both the individual price for each model and the number of unit sales of each model. Let's add the vehicle type field to columns. but that doesn't seem very useful, so let's remove that field, which we can do in two ways, either by using the drop-down menu, or if we undo that, we can also do it by simply dragging the field out of the columns section, either to the left over the worksheet or to the top over the fields list above. Let's now look at how to perform a simple calculation in a pivot table. If we look at the sum of price column in our pivot table, we can see that the figures are formatted as general. So first, let's change the format of these figures to US currency. This can be done by modifying the value field settings for the field in the relevant section of the pivot table fields pane. We'll format the field as US dollars and show no decimal places. Next, we'll add a calculated field from the Pivot Table Analyze tab using the Fields, Items, and Sets button. We want this field to calculate the total sales for each model by multiplying the price by the number of unit sales. When we create and add this formula, it gets added to the Pivot Table Fields pane as a field called Total Model Sales. And we can change the format to make it US dollars again. A new column called Sum of Total Model Sales has now appeared in the pivot table in our worksheet. In row 5, we can see that there have been over $360 million of sales of the Acura Integra model. And in row 7, we can see that there has been over $1 billion in sales of the Acura TL model. In this video, we learned how to format data as a table, how to create a pivot table, and use fields to analyze data in a pivot table, and how to perform calculations using pivot table data. In the next video, we'll look at some other features of pivot tables. Now that we've learned how to create and use pivot tables in Excel, in this video we'll look at some other features that we can use with pivot tables, including recommended pivot tables, filters, slicers, and timelines. First, let's look at recommended pivot tables, which isn't exactly a feature as such. It's really more of a list of suggested different combinations of data that could be used when creating a pivot table. These recommendations are based on the data we select in the worksheet, and they are a great way to get started creating pivot tables if you don't have much experience with them yet. For example, in the Vehicle Toy Sales worksheet, if we select column B, which contains data about the quantity of items ordered, when we choose recommended pivot tables from the Insert tab, then we are presented with a list of potential data combinations related to the order quantity information. However, if we select column F, which contains order size information, then the recommended pivot table list changes to reflect that data. And if we select column E, which contains sales information, then the pivot tables recommended are related to sales data. Let's select the third one down, which is the sum of sales by territory, because that sounds like something we could get some useful insight from by presenting it in a pivot table. Note that the new worksheet is opened containing the recommended pivot table, and a new pane opens on the right called Pivot Table Fields. Let's rename the worksheet to something more meaningful. In the Pivot Table Fields pane, you can see that some fields have already been added to the rows and values areas. Although it's a recommended pivot table, we can still make it our own by adding more fields, for example. So let's add the product line item to the columns area using drag and drop. Now we have columns for each of the product lines in our pivot table, such as motorcycles, ships, and trains. In the pivot table, we can manually expand any field we want to view its contents. Here, we can see that the order dates are located underneath the territory names in our pivot table. Note that this matches the order of the fields in the rows area of the Pivot Table Fields pane. We can manually collapse each of the fields too, but we also have the option of expanding all the fields at once and collapsing them all too. The next feature we will delve into is pivot table filtering. Pivot table filters work in much the same way as the standard filters we used earlier in the course. Note that we already have some inbuilt filtering in this pivot table. For example, the rows label header is a filter, and we can filter on any of the listed territories, such as Japan. Just like standard filters, it's very simple to clear a filter in a pivot table. We also have a column labels filter, allowing us to filter on any of the product line items in this pivot table. For example, we could show data only for the trains product. We also have the option of adding the product line field as a standard filter instead of a column heading by dragging it to the filters area in the pivot table fields pane. And we can then use it as a standard filter as we have done earlier in this course. The filter also allows us to select multiple filter items, but because it's now being used as a standard filter rather than a column header, we can't see the split of the information on these two product lines. We just see a combined total. When we had the filter as a column header, the information on each product line was presented separately in each column. Let's display all the field totals again, and we'll drag the product line field back to the columns area where it was previously, so we can see the split of our different product lines in the pivot table. The next pivot table feature we will look at are slicers. Slicers are essentially on-screen graphical filter objects that enable you to filter your data using buttons. Slicers make it easy to perform quick filtering of your pivot table data, and they also display the current filter state, making it easier for you to know and see what data is currently being shown and which is being hidden by the filter. For example, if we remove the product line field from the pivot table by dragging it out of the pivot table fields pane, and then from the pivot table analyze tab, we click Insert Slicer and then choose the territory field as our slicer, we can see that the slicer can be freely moved around anywhere on the worksheet, and it contains buttons for each of the territory names, such as EMEA, North America, and Japan. We can also select the Multi-Select button to filter on multiple territories if we wish. We can click the Clear Filter button to clear all the slicer filters. Let's add another slicer to our worksheet for the product line field. However, be sure to select a cell in the pivot table first, because if you don't, then the Insert Slicer button won't work. Note that slicers can also be added from the Filters group on the Insert tab, as well as from the Pivot Table Analyze tab. We'll select the product line field this time for our slicer and drag it near the top of the worksheet. As before, we can select only one slicer item, or we can turn on multi-select and choose several items to filter on in the slicer. Then let's clear the slicer filters. And now let's filter using both slicers. Note that when you use multi-select filtering, when you select an item, you are in fact filtering it out. That is, you are defining which items will not be displayed in the pivot table. This is the opposite behavior to when you were selecting single items in a slicer. So now we are displaying only classic cars, trains, and trucks and buses products for the EMEA and North America territories. Now let's clear those slicer filters and put the product line field back in the columns area of the pivot table, so it's ready for the next feature we will explore. And let's move these slicers out of the way further down the worksheet. The last useful feature for pivot tables we are going to look at is timelines. A timeline is another type of filter tool that enables you to filter specifically on date-related data in your pivot table. This is a much quicker and more effective way of dynamically filtering by date rather than having to create and adjust filters on your date columns. We can add a timeline for our pivot table either from the Pivot Table Analyze tab or from the Insert tab. Again, ensure you select any cell in the pivot table first. We'll select the Order Date field as our timeline filter. Then we can drag it up the worksheet and enlarge it. The default for this timeline is to display data by month, but you can also filter by days or by quarters. You can select a single quarter or you can select a range of quarters. In this case, we'll select 12 months between quarter 3 of 2003 and Q2 of 2004. You can use the Clear Filter button to clear a timeline filter. You can also filter by years. For example, here we have selected 2003 only. And you can combine slicers and timelines as filters in a pivot table. For example, here we can filter the slicers to display only data for trains in the EMEA and North America territories and only in the year 2003. And if we filter on the year 2004 instead, you'll see that there is no data being displayed, meaning that there were no sales of train products in 2004 in either the EMEA or the North American territories. Timelines and slicers have their own tabs in the ribbon when you select them, and their properties can be modified to change how they look and how they work. For example, let's change this timeline to a light green shade. And let's change this slicer to a nice orange color. And lastly, to remove a timeline or slicer, you can either select it and press the Delete key, or right-click it and choose Cut. In this video, we learned about some of the other features in Excel that we can use with pivot tables, namely recommended pivot tables, filters, slicers, and timelines. In this video, we'll give an overview of several different types of charts and visualizations, and discuss how they can be used to tell a story. Let's begin by looking at a line chart. When comparing different but related data sets, a line chart is a great way to display the information. They are able to display trends and show how a data value is changing in relation to a continuous variable. For example, if time is a continuous variable, how has the sale of a product or multiple products changed? Next, we have pie charts. This type of chart can show the breakdown of an entity into its subparts and the proportion of the subparts in relation to one another. Each portion of the pie represents a static value or category, and the sum of all categories is equal to 100%. In this example, we have a marketing campaign with 4 distinct categories: social sites, native advertising, paid influencers, and live events. With this type of data representation, we can easily see the total number of leads generated per category. We now look at one of the most commonly used charts, the bar chart. This type of chart is the most common as they are easy to create and are great for comparing related datasets or parts of a whole. For example, in this bar chart, we can see the population numbers of 10 different countries and how they compare to one another. We can also use stacked bars, in which each bar is divided into sub-bars that are stacked end to end. In this stacked bar, we can see the population of each country split into 4 age ranges. Would you like the graph to appear vertical and not horizontal? Then column charts would be a great pick. This type of chart can be used quite effectively to show change over time and to compare values side by side. For example, showing page views versus user session time on a website as it changes on a month-to-month basis. While this type of chart looks similar to a bar chart, they cannot always be used interchangeably. For example, a column chart may be better suited for showing negative and positive values. Next, we have tree maps, which are useful for displaying complex hierarchies using nested rectangles. In this example, the tree map depicts statewide employment rates within the population of a country over the last year. The size of the rectangle represents the population, and the color represents the employment rate. We can click on any region to see the employment data of the subregions within the selected region. Trying to display a pipeline or different stages of a continuous process? Then funnel charts are the way to go. In this example, the funnel chart is showing the conversion rate at each stage of the sales process, from lead generation to the final sale. Another exceptional chart is the scatter chart. In this type of chart, the circle colors represent the categories of data, and the circle sizes are indicative of the volume of data. For example, in this scatter chart, we can see each product line by the number of units sold and the revenue it brings. A scatter chart can be great for revealing trends, clusters, patterns, and correlations between data points. Next, we look at bubble charts. This is a variant of scatter charts, and they are useful for comparing a handful of categories to one another in terms of relative significance. For example, understanding areas of significant expenditure in an organization's sales budgets. Lastly, we have spark lines. Spark lines do not include an axis or coordinates, yet they display trends simply and effectively. These are great for showing the general trend of a variation. For example, stock market price fluctuations from the opening to the closing of a trading day. In this video, we learned about the importance of charts and how they are able to shape our data to provide meaningful information. In the next video, we will dive into more details about how to create and configure different types of charts in Excel.